All right, we have two substances here. They're both made of iron and oxygen. One is iron 2 oxide and the other one is iron 3 oxide. And we'll show you what that means in a second. Now you'll notice that even though they're both made of iron and oxygen, they're different. One is a red powder and the other is a black powder. So obviously there's some differences here with their physical properties, and if we were to go through and test their chemical properties, we would find some differences as well. Let's take a look at what is happening here and how do we show that there are differences between these substances that are made of the exact same elements. Those two substances we had were iron 2 oxide and iron 3 oxide. You'll notice that when we write them, they're a little different than the simple ionic compounds we've seen so far, because in brackets here we have some Roman numerals. So obviously this one being a Roman numeral for 3, so iron 3 oxide and iron 2 oxide. Now, iron falls in the transition metals, and we can see it here on the periodic table. And it's not one of the columns that we've worked with so far where we can quickly and easily identify the number of valence electrons. Now what's going on with iron is it's what we call multivalent. At times it has different numbers of valence electrons. At times it can have 3 valence electrons, and other times it can have 2 valence electrons. So when we're working with iron 2 oxide, how many valence electrons do you think it has? Well, it actually has 2 valence electrons. So really what this is telling me is what the charge is going to be. So when I'm trying to write the formula for these, it's actually no different than what we've done so far, and actually it's probably a little bit easier because it saves me one trip to the periodic table. I would write down the symbol, so Fe for iron, and then I would write down the charge. And so if it's iron 2 oxide, it's going to have 2 valence electrons, and therefore it's going to choose between losing 2 and gaining 6. It's going to choose to lose those 2 and become plus 2. Oxygen, we're going to write down the symbol O. It has 6 valence electrons, so its charge is minus 2. Iron, well, let's finish this one out. Then we're going to crisscross, 2 coming down, 2 coming down, Fe2, O2. We look, and then we realize, yes, we need to reduce FeO. So the formula for iron 2 oxide is FeO. For iron 3 oxide, we do the same sort of thing. Write down the symbol, 3 valence electrons, so its charge is going to be plus 3. Oxygen, again, is minus 2. We crisscross, Fe2, O3. So you can see the chemical formulas are quite different. This one has a different ratio of iron to oxygen, and therefore we can expect that, they might look and behave a little bit differently, and they do. So that explains it. And it all has to do with the fact that iron at times has different numbers of valence electrons. And there's a few other elements that we need to watch out for. It's not just iron. In fact, there's many, but we're going to worry about 4. We're going to give you iron, copper, tin, and lead. These are the 4 that we're going to watch out for. Okay? Now, they're easy to spot when we give you the names because they always have a Roman numeral with them. Now the compounds that involve the multivalent elements are a little bit trickier to name because now we're no longer just writing down the elements' names and slapping the IDE on the end. Now we need to indicate what the Roman numeral is in the middle. We need to indicate what its charge was. Well, how do we figure that out? Well, here's the steps. What we need to do first is we're going to do the reverse crisscross. Okay, so what we're going to do, let's take an example here of Cu2O. So really, there's a 1 right there beside the oxygen. We don't normally write that down, but for here I'm actually interested in it. What I'm going to do is I'm going to take this 2 and take the 1, and we're going to switch their spots. Okay, we're going to reverse them back up to the top. So I'm going to have Cu plus 1, oxygen minus 2. Now what I want to do is I've got to look at the charge on the non-metal. Okay, because this is never going to lie to me, because if it's been reduced, we're going to have a problem. We're going to have to fix it. We'll show you an example of that in a second. So I look, should oxygen have a charge of minus 2? And I check my periodic table. Yes, it has 6 valence electrons, so yes, it does want to have a charge of minus 2. So if this is correct, then that means that is correct. So what is the charge on copper? Well, the charge is 1. So I'm going to write down copper, then in brackets, I for Roman numerals, or 1, and oxide. So copper, 1 oxide. Now, for this example, here we've got Fe2S3. So what I do is I'm going to take the 2, bring it up to the top of the S, reverse crisscross, bring the 3 up. So we've got Fe plus 3, S minus 2. All right, once again, you check the charge on the nonmetal because it's never going to lie to you. Check, sulfur, 6 valence electrons, just like oxygen, it wants to be minus 2. Therefore, that's correct, so that is correct. This is going to be iron. What's its charge? Well, it's 3 sulfide. Okay, last example here. Let's get rid of this. Now I've got CuO. So really I've got 1 copper, 1 oxygen. Take these numbers up. Okay, reverse crisscross. Cu plus 1, oxygen minus 1. Should oxygen have a charge of minus 1? Is that correct? I checked the nonmetal and no, it's not. So this one has been reduced. So we need to fix it. How do we fix it? Well, what should oxygen's charge be? Well, we know it should be minus 2 because we were just working with it. So what do I need to multiply this number by to make it minus 2? Well, minus 1 times 2 will give me minus 2. So if I multiply this one by 2, I must multiply the copper by 2. Cu plus 2. So what's our name then? Well, now this is correct, so this is correct. So here we have copper 2 oxide. And that's about as tough as it's going to get. I want you to try the ones on the sheet now, try a couple examples, see if you can figure them out, and then we'll check your answers in a second.